Okay, now I will show you how to implement a stack using queue. So the problem is we have to implement a stack, but we will not use stack, but we will use queues to implement the stack. Okay, let's see how we will do it. So let's say I have, first of all, I can remove all this. Uh, I just have queues included here. I will not include here a stack because I'm not going to use the built-in stack from C++, but I'm going to use these built-in queues from C++ to implement a stack. So let us declare a class and call this class stack from queue, Q-U-E-U-E. So stack from queue class. So the name shows that we are going to make a stack from queues. So the logic is we have to kind of uh, implement, like we will use two queues for this. So first queue will be an queue of integers. Let's only focus on integers. Q1. Okay, it's with small letters, I think. Yeah, let's copy paste this. Control C, Control V. So the second is Q2. Yep. So we have defined two queues in this class. Now we know that stack has two functions, push and pop. So we are going to now implement those two functions. Let's call them two public functions. One public function is push, which should take an argument. It can be an integer argument, and the second public function is pop. To remove the elements of a stack, it should not take any argument. So we have to implement these two functions in this class. And we will implement these functions using these queues. Before, we have the stack push and stack.pop from C++, but not we will define our own push and pop for this stack from queue class, which is a stack, which is our own stack. So what this push will do, in the push we will simply, whatever element we will get, we will just do q1 dot push. And okay, this, let's say this integer is value, the variable name, and we will pass the value here. Yeah. Okay. Now this is our push function, simple as that. But our pop function, so the pop function will be a little bit complicated. Okay, first of all, this function will return nothing. Okay, this will return nothing. The pop function will return, it will pop up a value back. So this will be a little bit complicated. So first of all, if we will check if q1, this list q1 is empty, this sorry, then this function will return -1, nothing to do. Okay, let's say if q1 only has one element, so if q1 has one element, so let me explain you first this logic. So we have kind of two queues. One is Q1 and the other is Q2, and we are going to build a stack from this. So let's say Q1 has one element like 3, the other element is 2, and the last element is 1. So what we will do, we will put these two elements of Q1 into Q2. Like 3 will come here and 2 will come here. We'll first put 3 here, then we'll put 2 here, of course. So, and they will be removed from here. Now only one is remaining, this one. So what we will do, if this until this element, this one element is remaining, we will put all the elements of Q1 into Q2. After that, what we will do, we will create a temporary variable, a variable t, let's say, which is temporary, and we will put this one in this temporary variable equal to, sorry, is equal to 1. So this t will have this 1, so this 1 is also gone, and now Q1 is empty. So what we will do, we will then swap Q2 and Q1. So Q1 will then get 3 and 2 back, sorry, and Q2 will be empty, and then we will put 3 here from Q1 to Q2, and this will be removed, and only 2 will be remaining, and then this 2 will be assigned to the temporary variable, and then this is how the things will go. And then we will again kind of, you know, make Q2 empty and put all the Q2 elements in Q1, and then again check, you know. So this is what is actually the implementation of stack using the queues. So that's what we are doing here. So let's see, if Q1 dot size is not equal to 1, until it is not equal to 1, let's say put a while loop here. While it is not equal to 1, simply Q2 dot push should be Q1 dot pop. So pop the elements of Q1 and put them in Q2. Simple as that. And when there is only one element, so we have the case where Q1 is empty, we return -1. When Q1 is greater than 1, we push the elements of Q1 into Q2. Otherwise, we assign a variable temp, int temp is equal to temp is equal to Q1 dot front. The top element of Q1 goes to temp, braces, and then Q2 is equal to Q1. Actually, Q1 is equal to Q2 first. Actually, do a complete swapping here. Let's create another queue first of all. Let's do it like this. Okay, compile. No compilation error. So this is not a stack from from C++. This is my own stack. So just call this object my stack, and then my stack dot push. Let's put like 1 2 3. My stack dot push 4 5 6. My stack dot push 7 8 9. Okay, and then let's have a while loop. While my stack dot size but because we haven't defined such a function for size, so let's just remove it and simply, because this pop is returning an integer, let's do a cout my stack dot pop and then do a new line /n. That's it. So if I do it 2 times, if I do it 3 times, I will get my values in the reverse order. Let's see, compile. Okay, I have errors. Okay, this is private, this is private, this is private. Okay, let's see. If I make it public, okay, if I run 7 8 9 4 5 6 and 1 2 3, you see how I was able to implement my stack using the queues. So this is how I, so the logic, actually you must understand the logic. I'm normally a Java programmer, so I don't know the syntax of C++. I don't remember very well now, but somehow I was able to do it. But this is the logic that is most important here that you must understand. So we have declared, actually we have declared a class stack from queue. We are going to create a stack from queue. So we created 2 queues, q1 q2, and then we have a function push inside this class. This is simply pushing the integer value into the q1, and then we have a pop function that is actually doing the trick. If our q1 is empty, we return -1. There is nothing in the queue. If q1 size is greater than 1, means there are some elements, I take those elements one by one and I put them in q2. So I remove from q1, I put them in q2 and remove from q1. And then if there is only one element remaining, I put that element in a temporary variable. This is q1.front is doing this, and then I do a sorting, like I make q, because q2 has the rest of the elements of q1, so I assign q2 back to q1, and q2 is again empty. So, and q1 has its rest of the elements as before. So, and then I repeat this process. So this is how a stack is implemented. So copy this, call this queue, assign it to q1, and then so q1 is now q, so q1 is q2 and q2 is q. This is a complete swapping here, and then return temp. That's it. This is the pop function implementation. Now I need to create a main class which is already created, and in the main class I will use this stack from q, call it s. This is my own stack, which is equal to new. Do I need to create a new object, or I can do it without as well? Let's do it. Wait. So let's compile the program, execute, compile. We have errors here. Okay, so maybe we don't need this. Let's Control S, save, and compile again. Okay, now we have error here. We have a missing equal to. Okay, now compile again. Okay, push private void. Okay, so this is now a private void. It should be public void. I think that should be the syntax in C++. This one. Pop. Okay, q1.pop has an error. Push int value. Okay, so q1.pop cannot come here because this is a void. So let's do this. Do q1.pop after this, and let's put here q1.front because I will take the front element out, and then okay, now let's see. Okay, it should be like this. What error we have here? Conversion from stack q to okay. Okay, I'm missing here a semicolon. Let's save and run again. I removed this public from here because I don't need it. Actually, by default it is okay. So now there is something wrong here. I think this is not the way I should declare my class objects in C++. Maybe I'm using the Java syntax. Let's see. If we just do it like